let's look at some more examples of binomial probabilities. I'm going to take a die and I'm going to roll it out on the table and write down what I roll. I'm going to do that 10 different times. The outcome I'm recording is whether or not I roll a 3. So when we talked about this on the first video, we said this is a binomial experiment because I can reduce it to 2 possible outcomes, 3 or not a 3. The probability each time of my outcomes happening are the same. The outcomes are independent of each other, and I have a definite success or failure that I can conclude from that. So before I even start and determine, ask you what probabilities we're trying to find, our lowercase p, probability of success, I'm going to say success means I'm rolling a 3. And out of sides of the die, there are 6 sides of the die. There's only one number 3 on there. That's what I want. I want you to move down. If P is 1/6, then Q is 1 minus 1/6, or 5/6. Okay, and remember we said we're not going to use decimals here because 1/6 is not a terminating decimal. It repeats and it goes on, and that makes it, my rounded answer would be noticeably off if I'm not exact. So I'm going to leave 1/6 and 5/6. I'm rolling that die on the table 10 times, so n is 10. And x is the number of 3s that I roll. Number of 3s. So I'm going to do this experiment, and I want to know the probability that I roll exactly 3 3s. So my coefficient out in front, there are 10 times I'm repeating this experiment, and I want 3 successes. Remember, my P and my Q go here, and my P is raised to the power of x, which is how many successes I want. So if I want the probability that I will roll a 3 times, and I have 3 successes, which goes here, and so that means I have 7 failures. We could go back to the tree diagram. I'm hoping your book does that so I don't have to draw a bunch of trees out there, but it goes back to that adding up multiple branches of the trees. So 10 choose 3 is 120 if you want to write it separately. I guess I'll be official. And if we multiply these guys together, we get 0.155. So about a 15% chance of that happening, that I'd roll 3 3s. Find me the probability that we would roll 9 3s out of 10. Find me the probability that we would only roll 1 3, please, out of 10. So go ahead and pause the video. I'll check back in with you about this one, and then pause it again and check in about the next one. And you'll discover that the probability of us rolling 9 3s out of 10 rolls is very, very, very slim. Okay, most of you in your calculator will end up with something given to you in scientific notation. Instead of a 10 there, it'll probably have a capital E, but it means 8.27 times 10 to the negative 7th. So from where the decimal is, we're going to slide it to the left 7 places, and so really there's not a chance that that's going to happen. It's so small we aren't going to worry about it. Okay. Now the probability that we would roll 1, 3, and 9 of something else, okay, is a little bit more likely to happen. You'll find out. Here is the expression that you'll look at, and when you multiply that out, about a third of the time, okay, if I rolled a die 10 times and you did, and your neighbor did, and everybody in the class did, about a third of us would end up with only 1 3, and exactly 1 3. Let's say that we've got a player. When I taught at Coffeyville, we had a men's basketball player that was in the 90% range with his free throws during the game. And Devin, if he were to shoot 7 free throws in a game, I want to know the probability that he'd make only 2 of them. Okay, so exactly 2 and only 2. In a minute, I want you to pause the video and set these things up. Okay, when you're done with that, figure out the probability that he would make exactly 6 of them. And then go back and find the probability that he would make 3 or more of them. Okay, so find me those probabilities and then turn the video back on. The probability that Devin's going to make only 2 of his shots out of 7 means out of the 7 that he shoots, the n is 7, we're going to choose 2 of them. He is going to make 2 of those shots, which means he's going to miss 5 of them. And these exponents here need to add up to 7 out of 7 total shots. The probability if he makes 90% of his free throws, overall the probability of success is 0.9 and the probability of failing is 0.1. And so, again, very slim chance he's going to have a really off night for that to happen. The probability that Devin will make 6 of those free throws. Out of the 7 that he shoots, we're choosing 6. He's going to make 6 of them, and he's going to miss 1 of them. Okay, a little over a third of the time, 37% of the time that's going to happen. If we want to find the probability he's going to make 3 or more of them, okay, that task gets a little bit daunting because I say, well, he might make 3 or 4 or 5 or 6 or 7 or 8 or 9 or 10 of them. Okay, and so then I get to practice the formula 8 times. 7, if you, well, out of the 8 times I'd have to do 6 more because I've already done 2. So 6 I wouldn't have to redo, but I'd have to do 3, 4, 5, 7, 8, 9, and 10. So hopefully some of you out there figured out a little shorter path we can take. And if not, then I want to put that idea in your head again right now. Okay, instead of figuring out 3, 4, 5, 6, 7, 8, 9, and 10, sometimes the complement of that event is smaller. Meaning finding the probability that he's going to make 2 of them, or 1 of them, or 0 of them. I only have to find 3 probabilities. Probability that he makes 2, or 1, or 0. Okay, and I did already find the probability that he makes 2 up above. I can scroll back up for that. And then once I find the probability that he's going to make 2, 1, or 0, I can subtract that from number 1. Okay, 1 is everything. So I could subtract that from 1, and what I'm left with should be this piece that I bet at least some of you sat down and worked all the way through and said mean nasty things under your breath as you were doing that. So go ahead and pause the video if you haven't already. If you did work this one to the end, compare your answers. And if you didn't, then good for you for waiting because this way is going to be shorter. So the probability that he would make 2 of his 7 free throws we found before. The probability that he'd only make 1 of them and miss 6, a whole bunch of zeros, and then a 6, 3. The probability that he's going to miss all 7, he's going to make 0 free throws and miss all 7 is 6 zeros and then a 1 past the decimal. If we add all of those up, this is the probability that he's going to make 2 or 1 or 0 free throws. So this is the complement of the event we were trying to find. We said, what's the probability he'll make 3 or more? Okay, so if we add up the probability that he'll make 3 and 4 and 5 and 6 and 7 and 8 and 9 and 10, we should get pretty much 100% of the time. Hundreds, thousands, 10,000s. To the nearest 10,000s place, it's 99.98% chance that he's going to do this. But we take away this probability that we found from 1, gives us the complement, which is what we were asked to find. Okay, here we only had to find 3 probabilities instead of 8. So shorter path to take. Please be in touch with me, be in contact. If you have questions and you need to see more examples, get with me on Zoom and we can work some more problems out one-on-one.